and welcome to this video looking at genetic drift. We're going to be looking at the two different ways that genetic drift can arise, and this is from genetic bottleneck or from the founder effect. Genetic drift in general then is if a population descends from a small number of parents, the gene pool will lack genetic variation. So if we have a gene pool here where it's a small number of parents, we might only have two alleles. We might only have capital A, lowercase a. So that's lacking variation. So if a catastrophic event occurs, such as like an earthquake, a flood, disease, and it's going to lead to the death of many of the already small population. So we've got like flood, earthquake, disease, etc. Then we're going to have many offspring dying. And one of these alleles might actually disappear from this population. So it might be that this capital dominant A is lost due to the deaths caused by any of these. So actually we're only left with a recessive A allele in this new population. So when the population recovers and increases in size, it will have less genetic diversity than before and may lack particular alleles. So the alleles in question did not disappear due to selection pressures, but due to genetic drift. So, like we've said, this can occur through either genetic bottlenecking or through founder effect. Genetic bottlenecking I'll do first in red. Okay, so this is when a population size shrinks and then increases again. So we've got a population, let's say go from 100, 10, back to 100. Okay, so it's gone through a bottleneck, that kind of idea. So after the event, the genetic diversity will have reduced. Here we can see reduced diversity, okay, in the genetics. So there may be less of the advantageous alleles or disproportionate frequencies of the harmful alleles. So long-term survival is at risk here. So it might be that at this point we only actually have this recessive A allele. So then as this is going to get bigger, we're going to have more of that in the allele frequencies. So sometimes population size is so low that fertility is affected. So it could become extinct, that is one risk. Extinction. However, if those who survived have advantageous alleles such as resistance to a pathogen, it could improve the gene pool here. So it could actually be improved gene pool, but that is not for certain. Okay. So that's a genetic bottleneck. And if we're looking at the founder effect, here. So this is when if a new population is established by a very small number of individuals who originate from a larger parent population. So if I drew this out, so if we had a larger population going into a very much smaller population, the new population is likely to exhibit a loss of genetic diversity. So if we had, I'm just going to represent different alleles in different colours here. So if we had quite a few different alleles in the parent population, which is going to be a larger population. So then if we went into a smaller population, we might only have 2 different kinds of alleles. And it might be that just by chance these are the disadvantageous, or it might be that they are advantageous or neutral. But as we can see, there's going to be a loss of diversity, okay, or loss of variation. So this newly pollinated area has different allele frequencies compared to the parent population due to inbreeding. So these green and red can only interbreed. So there's going to be a high proportion of those in the future generations. So allele frequencies are affected by this. We've got quite a few similarities between these 2 ways of causing genetic drift as well. I'll just go through a couple of them because it might come up in an exam question, it might not, but it's just good to make those links between the 2. So they both involve small numbers of individuals, so they both involve small populations. Both followed by genetic drift. The initially genetic diversity is lost in both, so there's a loss of diversity in both of them, and both can have rise of new alleles. And then we have a small number of individuals that breed together. So here and here, we've got a small number of individuals breeding. Okay. Okay, but then we've got that this one is by like migration. This one is through a disaster such as these here. Okay. Right, that's everything for genetic drift. Thank you for watching.